Microsoft Fabric Security Deep Dive, the complete enterprise guide to protecting data, identity, networks, governance, and analytics at scale. Hello and welcome. In this session, we are going deep into Microsoft Fabric Security, not as a single feature, but as a complete security architecture for enterprise analytics. Fabric combines data engineering, data integration, data warehousing, real-time intelligence, data science, and Power BI into one SaaS platform that creates speed, but it also creates responsibility. When more teams can create, move, transform, model, and share data, security has to be designed into every layer. We will look at identity, access, OneLake, workspace roles, network protection, encryption, compliance, governance, monitoring, and operational best practices. By the end, you should be able to explain how Fabric security works and how to design a secure Fabric environment. The first big idea is that Microsoft Fabric is built as a SaaS platform. That means many security responsibilities that were traditionally handled by platform teams are built into the service by Microsoft. The platform handles core infrastructure security, patching, encryption, authentication integration, reliability, and continuous improvement. But SaaS does not remove customer responsibility. Organizations still decide who can access Fabric, which workspaces exist, how data is classified, what can be shared, what network paths are allowed, and how sensitive data is monitored. So Fabric security is a shared model. Microsoft secures the platform foundation, while customers configure identity, governance, access, compliance, and secure usage. A useful way to understand Fabric security is to think in layers. The first layer is identity, where Microsoft Entra ID authenticates every user and service principal. The second layer is tenant and platform access, where administrators decide how Fabric is enabled and governed. The third layer is workspace security, where teams collaborate and permissions are assigned. The fourth layer is item and compute security, where individual lakehouses, warehouses, reports, semantic models, and SQL endpoints can have their own controls. The fifth layer is OneLake data security, where access to tables, folders, and files is governed. The final layers are network security, encryption, monitoring, compliance, and governance. Fabric security model follows zero trust principles. Zero trust does not mean nobody is trusted to do work. It means every request must be verified, access should be least privilege, and security should assume that risk can exist inside or outside the network. In Fabric, this starts with Microsoft Entra ID authentication. It continues with conditional access, workspace roles, item permissions, data permissions, sensitivity labels, audit logs, and network restrictions. The important point is that access is not granted just because someone is inside a corporate network. Access should depend on identity, device health, location, role, data sensitivity, and business need. Authentication in Fabric is handled through Microsoft Entra ID. When a user opens Fabric in a browser, Power BI desktop, or another client, Entra ID validates the user and issues tokens. Fabric uses those tokens to understand who the user is and what action should happen in that user's context. This is important because Fabric does not need a separate identity system for each analytics workload. The same identity platform can support Power BI, Data Factory, Lakehouse, Warehouse, Real-Time Intelligence, and other Fabric experiences. This also allows administrators to apply consistent sign-in rules across the Microsoft Cloud ecosystem. Conditional access is one of the most important identity-based controls for Fabric. It allows organizations to define access policies based on signals such as user identity, group membership, device compliance, location, sign-in risk, and application context. For example, an organization can require multi-factor authentication for Fabric access. It can block access from unmanaged devices. It can restrict access from certain countries or regions. It can require users to connect only from approved IP ranges. Conditional access is powerful because it protects the front door before users reach workspaces, reports, notebooks, pipelines, or OneLake data. A common mistake is to configure conditional access too narrowly. Fabric works across multiple connected services, and some experiences depend on Azure Storage, Azure SQL, Azure Data Explorer, Azure Cosmos DB, Power BI, and other Microsoft resources. If a policy allows only one service and blocks downstream dependencies, users may experience broken features or repeated sign-in prompts. A better approach is to design a common conditional access policy for Fabric and its connected services. This creates a more consistent experience and reduces unexpected failures. Security should be strict enough to reduce risk, but designed carefully enough to support the platform's real workflows. Authorization is different from authentication. Authentication confirms who the user is. Authorization decides what the user can do. In Fabric, permissions are stored and evaluated centrally through the platform's metadata services. When a user tries to access a workspace, open a report, query a table, run a notebook, refresh a semantic model, or manage a pipeline, Fabric checks the relevant permissions. This matters because one person may be allowed to view a report but not modify it. Another person may manage a pipeline but not see sensitive tables. A secure Fabric design always separates identity verification from actual permission enforcement. Fabric permissions should be understood as a chain. A user first needs to authenticate through Microsoft Entra ID. Then the user needs access to Fabric. Then the user needs access to the relevant workspace, shared item, or app. Then the user may need compute level permissions through a SQL Analytics endpoint or semantic model. Finally, the user may need OneLake data permissions to access tables, folders, or files directly. If any required layer is missing, access may fail. This layered model is useful because it allows broad collaboration while still protecting sensitive data through more specific controls. Workspaces are the primary collaboration and security boundary in Fabric. A workspace groups related Fabric items, such as lakehouses, notebooks, warehouses, pipelines, reports, semantic models, and dashboards. Workspaces usually represent a project, department, domain, product team, or business function. A good workspace design makes security easier. For example, finance data, healthcare data, operational telemetry, and public reporting should not all live in the same workspace. Separating workspaces by domain and sensitivity helps administrators assign appropriate roles, apply network rules, manage capacity, and monitor access. Workspace design is one of the earliest and most important security decisions in Fabric. Fabric workspace roles include admin, member, contributor, and viewer. Admins can manage the workspace and permissions. Members can collaborate, modify, and share content. Contributors can create and modify content, but have fewer management capabilities. Viewers can view content, but cannot modify it. These roles are convenient, but they can also be broad. Giving someone workspace admin or member access gives them significant influence over the workspace. The safest model is to use Entra security groups, assign roles based on job function, and review membership regularly. Avoid assigning powerful workspace roles directly to many individual users. The viewer role deserves special attention. Viewers can see content in the workspace, but their data access may still depend on other controls. In some cases, viewers can run SQL, DAX, or MDX queries, but they may not have direct OneLake access or notebook access. This is why the word viewer can be misleading if teams do not understand the access path. Viewing a report is not always the same as querying files directly. Viewing a workspace item is not always the same as accessing all underlying data. Security teams should test access paths instead of relying only on role names. Item permissions provide more precise access than workspace roles. Instead of granting a person access to an entire workspace, you can share a specific report, semantic model, lakehouse, warehouse, or other Fabric item. This is useful when consumers need access to one asset, but should not see everything in the workspace. For example, a sales executive may need one Power BI report, but not the underlying engineering notebooks or data pipelines. Item permissions support least privilege by narrowing the access scope. However, administrators must remember that item permissions and workspace roles interact. Removing item access may not block a user if workspace access still grants visibility. Power BI apps are often better than broad workspace access for report consumers. Many business users only need a curated set of reports and dashboards, not access to the workspace where those reports are built. Apps allow report creators to package content and distribute it to audiences in a controlled way. This is especially helpful when the workspace contains development artifacts, semantic models, lakehouses, or pipelines that business viewers should not touch. Apps help separate creators from consumers. This separation is a basic security principle because it reduces accidental changes, limits unnecessary visibility, and supports cleaner governance. Compute permissions add another security layer. Fabric data can be accessed through different compute engines, such as SQL Analytics endpoints, warehouses, and semantic models. A SQL Analytics endpoint can enforce SQL permissions for users who query tables through SQL. A semantic model can enforce DAX-based security for Power BI reports and model queries. These permissions are not always identical because they apply to different access methods. This is why organizations need to design security for every path users may take. If users can access the same data through SQ Direct Lake, reports, notebooks, and shortcuts, every path must be controlled. Row-level security, column-level security, and object-level security help limit what users see inside a dataset or query experience. Row-level security restricts rows, such as allowing regional managers to see only their region. Column-level security restricts columns, such as hiding salary or patient identifier fields. Object-level security can hide tables or objects from certain users. These controls are essential when many users need access to the same model or database but should not see the same data. The key is to align these rules with business roles, test them with real user identities, and document how the rules are applied. Direct Lake introduces both performance benefits and security design considerations. Direct Lake allows Power BI semantic models to read data directly from OneLake without importing it into a traditional model storage layer. This can improve performance and reduce duplication, but it also means report access and OneLake access must be understood together. If security is defined in the SQL Analytics endpoint, Direct Lake behavior may fall back to direct query for affected tables. If organizations want Direct Lake without unexpected fallback, they need to design semantic model security, SQL security, and OneLake permissions carefully. Direct Lake is powerful, but it should not be treated as security neutral. OneLake is central to Fabric security because it is the unified logical data lake for the tenant. It stores structured and unstructured data used by Fabric experiences. Lakehouses, warehouses, and other Fabric items can store their data in OneLake. The value of OneLake is that organizations can reduce data copies and give teams a common data foundation. The security challenge is that a unified lake requires unified governance. If many workloads can read from the same lake, access must be managed consistently. OneLake security is where file, folder, table, shortcut, and cross-workspace access become critical. OneLake security allows organizations to control access to specific tables and folders in a lakehouse. Instead of granting everyone broad access to an entire workspace, custom OneLake roles can grant read access to selected data. Users, security groups, or workspace role-based assignments can be added to these roles. This is important for sensitive data domains. For example, a lakehouse may contain customer demographics, transaction history, and support records. Not every analyst should read every folder or table. OneLake security helps reduce the need to split data into many copies just to enforce access boundaries. OneLake shortcuts are useful because they allow data to be referenced without copying it into OneLake. A shortcut can point to another storage location or shared data source. This supports data virtualization and reduces duplication. But shortcuts do not remove security requirements. Access is still enforced at the source. If a shortcut points to data controlled by another workspace, tenant, or external storage account, users still need appropriate permissions. In cross-tenant scenarios, the source tenant controls access. The consuming tenant cannot simply bypass those permissions by creating a shortcut. This is an important governance principle for distributed data sharing. Cross-tenant data sharing requires extra care. Many organizations collaborate with partners, subsidiaries, suppliers, or external analytics teams. In Fabric, external users may authenticate through their home Microsoft Entra tenant, but they still need explicit access to shared data in the source tenant. If a Power BI report uses Direct Lake over shared OneLake data, the recipient may need both item-level permission on the report and OneLake permissions on the underlying shared tables. This is different from simple report viewing. Security architects should define clear patterns for external sharing, approval workflows, data owner review, and periodic access recertification. Workspace identity is one of the most important features for secure data access. A workspace identity is an automatically managed service principal associated with a Fabric workspace. Fabric can use this identity to authenticate to supported resources using Microsoft Entra ID. This reduces the need to store passwords, secrets, or certificates inside pipelines, notebooks, and connections. Workspace Identity supports secure access to resources such as ADLS Gen 2 when configured correctly. It can also support trusted workspace access. In practical terms, Workspace Identity helps teams move towards secretless authentication and away from fragile credential handling. Workspace Identity also introduces governance responsibilities. Because it is a service principle, anyone who can use it may be able to opt through that identity. Therefore, access to configure or use Workspace Identity should be limited to appropriate workspace roles and monitored. Workspace admins can create and delete workspace identities, but deletion can break Fabric items that rely on the identity. If a workspace is deleted, its identity is deleted as well, and restoring the workspace does not automatically restore the same identity. Security teams should document where workspace identities are used and monitor related audit events. Trusted workspace access is useful when Fabric needs to connect securely to firewall-enabled Azure Data Lake Storage Gen 2 accounts. With trusted workspace access, a Fabric workspace that has a workspace identity can be allowed to access selected storage resources. This supports scenarios where storage accounts restrict public access but still need to be available to approved Fabric workspaces. The key idea is that access can be granted to a workspace identity rather than opening broad network paths or using stored secrets. This makes the connection more specific, manageable, and aligned with least privilege. Managed private endpoints help Fabric connect securely to external data sources without exposing those sources to the public internet. For example, a data engineering workload may need to connect to an Azure SQL database, storage account, or other private endpoint-enabled service. Instead of allowing public connectivity, a managed private endpoint provides a controlled private path. This is especially important for regulated environments where data sources must remain inside approved network boundaries. Managed private endpoints are part of outbound network security. They help ensure that Fabric can reach what it needs, but only through approved private connections. Outbound access protection is designed to reduce data exfiltration risk. When outbound access protection is enabled for a workspace, supported Fabric items such as notebooks, Spark job definitions, lakehouses, and environments can be restricted from making arbitrary outbound connections to public endpoints. Instead, access must be explicitly allowed through approved managed private endpoints or configured exceptions. This matters because analytics workloads can process sensitive data, and code-based workloads such as notebooks can potentially send data elsewhere if unrestricted. Outbound access protection turns the default posture from open outbound communication to controlled outbound communication. Inbound network protection focuses on controlling where access to Fabric can originate. Fabric supports tenant-level and workspace-level inbound controls. Tenant-level controls apply broadly across the Fabric tenant and may include tenant-level private link and conditional access. Workspace-level controls can apply to individual workspaces and may include workspace-level private link and workspace IP firewall rules. This layered model is useful because not all workspaces have the same sensitivity. A public dashboard workspace may not need the same inbound restrictions as a healthcare analytics workspace. Security should be proportional to data sensitivity and business risk. Private link routes traffic through Azure private networking instead of relying only on public internet paths. Fabric supports private link at tenant and workspace scopes. Tenant-level private link secures access broadly across the tenant. Workspace-level private link gives administrators more granular control for specific workspaces. This is valuable when a highly sensitive workspace needs stronger inbound restrictions without forcing the same pattern on every workspace immediately. Private links should be combined with identity controls. A private network path reduces exposure, but it does not replace authentication, conditional access, workspace roles, item permissions, or data security. Workspace-level private link can affect how events and integrations work. Fabric events, workspace item events, OneLake events, and Azure events may behave differently depending on whether tenant-level or workspace-level public access is blocked. For example, if public access is blocked on a source workspace, consumers in other workspaces may need an appropriate private link path to consume events. Azure event sources may also be blocked when public internet access is disabled. This shows why network isolation decisions must be tested against real workflows. Strong isolation can improve security, but it can also interrupt event-driven architecture if dependencies are not planned. Service tags and IP allow lists support scenarios where private networking is not enough or not available. Azure Service Tags can help allow traffic from known Azure services or Fabric-related service ranges. IP allow lists can help organizations permit traffic to and from Fabric when data sources are outside Azure or do not support service tags. These controls are useful, but they require operational discipline. IP ranges and service dependencies can change over time. Administrators should avoid creating unmanaged firewall exceptions that nobody reviews. Network rules should be documented, owned, tested, and periodically validated against current Fabric and Azure requirements. Data gateways are important when Fabric needs to reach on-premises or private network data sources. The on-premises data gateway acts as a bridge between Fabric and local data sources. It is installed inside the organization's network and allows Fabric to connect securely without opening inbound firewall ports. The Virtual Network Data Gateway supports connectivity from Microsoft Cloud Services to Azure Data Services inside a virtual network. Gateways are often used for refresh, pipelines, data flows, and hybrid analytics. Security teams should treat gateways as critical infrastructure because they can provide access to sensitive internal systems. Gateway security depends on deployment and operations. The server hosting an on-premises gateway should be hardened, patched, monitored, and protected like any other critical integration server. Gateway administrators should be limited. Connections should use least privileged credentials. High availability gateway clusters should be considered for important workloads. Gateway logs and usage should be reviewed. A common risk is that teams create gateways for convenience and then forget them. In a secure Fabric environment, gateways should be inventoried, assigned owners, aligned with business workloads, and decommissioned when no longer needed. Encryption at rest is built into Fabric. Fabric data stores are encrypted using Microsoft managed keys by default. This includes customer data, system data, and metadata. Data may be processed in memory in an unencrypted state because computation requires readable data, but it is not persisted to permanent storage in an unencrypted state. This default encryption reduces baseline risk and supports compliance requirements. However, organizations with stricter regulatory or internal requirements may need more control over encryption keys. That is where customer-managed keys become relevant. Workspace customer-managed keys allow organizations to use their own Azure Key Vault keys to encrypt the Microsoft encryption key for specific Fabric workspaces. This adds another layer of control for organizations with compliance, contractual, or data sovereignty requirements. Customer-managed keys can support stronger governance around key ownership, rotation, and separation of duties, but they also increase operational responsibility. If key access is removed, the key is disabled, or the vault is misconfigured, Fabric workloads may be affected. Customer-managed keys should be implemented with change management, monitoring, documented recovery steps, and clear key ownership. Key vault configuration matters when using customer-managed keys. Soft delete and purge protection should be enabled to reduce the risk of accidental or malicious key loss. The Fabric platform needs appropriate permissions to get, wrap, and unwrap keys. Keys should meet supported type and size requirements. Versionless key identifiers are important because Fabric checks for new versions and can use the latest available key version. Administrators should avoid disabling older key versions too quickly after rotation. Encryption control is powerful, but mistakes in key lifecycle management can become availability incidents. Data in transit is also protected. Fabric communications use TLS, enforcing modern transport security for inbound communication and requiring supported TLS versions for outbound communication to customer-owned infrastructure. Traffic between Microsoft services travels over Microsoft's global network. This helps protect confidentiality and integrity while data moves between services, clients, and workloads. However, encryption in transit does not replace access control. A securely encrypted connection can still expose data if the wrong user has permission. Transport security protects the channel. Identity, authorization, and governance protect the data. Data residency is a major concern for global organizations. Fabric tenants have a home region for metadata, and capacities can be assigned to specific geographies. With multi-geo capacities, organizations can place compute and storage in regions that align with business and regulatory needs. This supports scenarios where companies operate in multiple countries and must keep certain data at rest in specific regions. But teams must understand what stays in the capacity region and what may remain in the tenant home region. Data residency is not just a checkbox. It requires architecture decisions, capacity planning, and governance review. Multi-geo design should be tied to data classification. Highly regulated data may require specific regional storage and processing. Less sensitive operational data may have broader placement options. Administrators should define which business domains can use which capacities, who can create workspaces in each region, and how exceptions are approved. Workspace placement should be part of the data product lifecycle. Before a team creates a lakehouse or warehouse, it should understand the data's residency, privacy, and sovereignty requirements. This prevents accidental placement of sensitive data in an inappropriate geography. Governance in Fabric is strongly connected to Microsoft Purview. Purview helps organizations classify, protect, discover, audit, and govern data across the estate. In Fabric, Purview integration supports sensitivity labels, lineage, endorsement, discovery, data loss prevention, and governance experiences. The goal is to create visibility and control without stopping analytics work. Governance should help users know which data is trusted, which data is sensitive, where data came from, and how it is being used. Without governance, Fabric can grow quickly but become difficult to manage. With governance, Fabric becomes a more trusted analytics platform. Sensitivity labels help classify data according to business risk. Labels such as general, confidential, or highly confidential can be applied to Fabric items and can follow data as it moves through supported experiences. This is important because data does not stay still. It may move from a lakehouse to a semantic model, from a semantic model to a report, and from a report to Excel, PowerPoint, PDF, or PBX. Labels help preserve context as data moves. They also help users understand handling expectations. A label is not just decoration. It is a signal for protection, monitoring, policy, and responsible use. Data loss prevention policies help detect and reduce risky handling of sensitive data. In Fabric and Power BI scenarios, DLP can identify sensitive information types and apply policies that warn, audit, or restrict certain actions. This is especially useful when users create self-service reports and models. A report creator may not realize that a dataset contains personal information, financial identifiers, health data, or confidential business records. DLP helps bring policy into the workflow. It does not eliminate the need for training and data ownership, but it adds automated guardrails where human judgment alone may fail. Lineage is a security and governance capability, not just a documentation feature. Data lineage shows where data came from, how it was transformed, and where it is consumed. In Fabric, lineage can help teams understand the impact of changes, identify downstream reports, and investigate data exposure. For example, if a sensitive table is discovered in a lakehouse, lineage can show which semantic models and reports depend on it. That makes incident response faster. It also helps with compliance because auditors and governance teams often need to understand how data flows from source systems to business users. Audit logs are essential for accountability. Fabric administrators and security teams need to know who accessed what, who shared what, who changed permissions, who created identities, who deleted assets, and who exported data. Audit logs support investigations, compliance reviews, and operational monitoring. They also support proactive governance. For example, administrators can review workspaces with too many admins, users sharing sensitive reports externally, unusual activity by service principals, or changes to workspace identities. A secure Fabric environment should not wait for incidents. It should continuously review audit signals and respond to risky patterns. Fabric administration should be delegated carefully. Tenant administrators control broad platform settings. Capacity administrators manage capacity level concerns. Workspace administrators manage workspace content and access. Domain owners may govern data products for a business area. Security and compliance teams define policies and monitor risk. This separation of duties prevents one group from becoming a bottleneck while still keeping control. The danger is unmanaged delegation. If every team becomes its own administrator without standards, security becomes inconsistent. A mature model gives teams autonomy inside clearly defined guardrails. Tenant settings are one of the main ways administrators create guardrails. Tenant settings can control who can create Fabric items, who can share externally, who can use specific features, who can publish to web, who can export data, and which workloads are enabled. These settings should be reviewed before broad Fabric rollout. The safest approach is usually stage enablement. Start with trusted groups, validate controls, define operating procedures, and then expand. This avoids opening powerful capabilities to the entire organization before governance, monitoring, and support processes are ready. Fabric feature availability varies by workload and item type. Not every security feature applies equally to every Fabric item. Workspace private links, customer managed keys, and outbound access protection may be generally available for some item types, in preview for others, and unavailable for others. This matters when designing secure workloads. A feature that protects a lakehouse may not protect every Power BI item in the same way. Architects should check feature support before promising a security pattern. Secure design must be based on actual workload capabilities, not assumptions that every Fabric experience behaves identically. Data engineering workloads need particular attention because they often involve code, external libraries, data movement, and broad source system connectivity. Notebooks and Spark jobs can read, transform, and write large data sets. If outbound access is unrestricted, code can potentially reach destinations outside approved boundaries. If workspace roles are too broad, too many users can modify production transformations. A secure data engineering pattern should separate development, test, and production workspaces. It should use source control and deployment pipelines where appropriate. It should restrict outbound access, use managed private endpoints, and avoid hard-coded credentials. Data factory pipelines and data flows also require strong controls. They connect to many sources and destinations, often using starred connections or gateways. A pipeline can move sensitive data at scale, so its permissions matter. Connection credentials should be managed securely, preferably with identity-based authentication where supported. Pipeline ownership should be clear. Production pipelines should not be editable by everyone in a workspace. Changes should follow review and deployment practices. Monitoring should detect failures, unusual volume changes, and unexpected destination writes. Data movement is one of the highest risk activities in any analytics platform. Data warehouse and SQL endpoint security should be familiar to database teams, but adapted to Fabric. Warehouses and SQL analytics endpoints can support SQL-based permissions and fine-grained access patterns. This is valuable for analysts and applications that rely on SQL. However, Fabric data may also be accessible through OneLake, semantic model, shortcuts, and reports. Database permissions alone may not protect every path. Teams should define which access path is authoritative for each audience. For example, business users may consume through Power BI apps, analysts through SQL endpoints, and engineers through Lakehouse access. Each path needs matching security controls. Power BI security remains central because it is often the most visible part of Fabric. Reports and dashboards may expose data to executives, frontline employees, partners, or customers. Power BI supports workspace roles, app audiences, sharing, semantic model permissions, RLS, OLS, sensitivity labels, export controls, and embedded analytics patterns. The main design question is simple. Should users only see curated analytics, or should they also access the underlying data? Many consumers should receive reports through apps, not workspace membership. This reduces the risk of accidental access to datasets, models, pipelines, and development assets. Embedded analytics adds another security model. In Embed for Your Organization scenarios, users authenticate through Microsoft Entra ID, and organizational policies such as RLS and permissions apply. In Embed for Your Customer scenarios, an application may authenticate users outside the organization and use embed tokens to control what each user can access. This places more responsibility on the application owner. The application must correctly authenticate users, generate tokens with proper permissions, enforce tenant isolation if applicable, and protect embed token handling. Embedded analytics can be secure, but it requires careful architecture beyond simply placing a report inside an iframe. Mobile access also matters. Users may access Power BI reports and Fabric-related content through mobile devices. Mobile security depends on device communication, token storage, app protection, and mobile device management. Microsoft Intune can help protect corporate data with app protection policies, encryption, conditional access, and device compliance checks. Organizations should decide whether unmanaged personal devices can access sensitive analytics. They should also define rules for offline caching, biometric access, screenshots, copy and paste, and data export. Mobile analytics is convenient, but convenience should not bypass sensitivity requirements. Resiliency and recovery are part of security because availability is the security outcome. Fabric includes platform reliability capabilities, and Microsoft manages much of the SaaS infrastructure resilience. However, customers still need operational plans. They should understand what happens if a workspace is deleted, if a workspace identity is removed, if a key is disabled, if a gateway fails, if a pipeline is changed, or if a report is accidentally shared. Recovery is not only disaster recovery, it includes configuration recovery, permission recovery, identity recovery, and governance recovery. Secure operations require backups of decisions, not just backups of data. Compliance in Fabric should be viewed through shared responsibility. Microsoft provides a cloud platform built with security and compliance practices, but customers are responsible for how they use it. If a company stores regulated healthcare, financial, government, or personal data in Fabric, it must configure access, classification, retention, sharing, and monitoring appropriately. Fabric can support compliance goals, but it does not automatically make every workload compliant. Compliance depends on architecture, policies, evidence, approvals, training, audit logs, and controls mapped to specific regulations. The platform provides capabilities. The organization must turn them into governed practice. A practical security baseline for Fabric should begin with identity, require multi-factor authentication for privileged users and sensitive access. Use conditional access for device compliance and location restrictions. Use Entra security groups instead of assigning permissions to individuals everywhere. Define admin groups separately from creator groups and consumer groups. Limit tenant-wide administrative roles. Monitor service principals and workspace identities. Disable or restrict risky sharing capabilities until governance is ready. Identity is the control plane for almost every other Fabric security decision, so it should be designed before large-scale adoption. The second baseline area is workspace and data design. Create workspace based on domains, sensitivity, lifecycle, and ownership. Avoid mixing unrelated sensitive and non-sensitive data in one workspace. Use separate workspaces for development, testing, and production when workloads are important. Use item permissions and apps for consumers instead of giving broad workspace access. Use OneLake roles for table and folder level access. Apply RLS, CLS, and OLS where business users need filtered views. Review workspace admins, members, contributors, and viewers on a schedule. Good workspace hygiene prevents many future security problems. The third baseline area is network and connectivity. Decide which workspaces require private link, IP firewall rules, managed private endpoints, outbound access protection, or trusted workspace access. Use gateways for on-premises data sources and manage them as critical infrastructure. Avoid opening public network access just to make a connection easier. Prefer identity-based authentication and private paths where supported. Document every exception, especially firewall allow lists and gateway connections. Test network controls with real workloads, such as pipelines, notebooks, reports, event streams, and refreshes. Network security should protect data without silently breaking essential analytics flows. The fourth baseline area is governance and monitoring. Apply sensitivity labels to important Fabric items. Use Microsoft Purview to support discovery, lineage, audit, and policy enforcement. Configure DLP policies for sensitive information. Monitor audit logs for sharing, exports, permission changes, identity events, and unusual access. Create a review process for workspaces with sensitive data. Define owners for data products and require them to approve high-risk sharing. Governance should not be a one-time setup. It should be a continuous operating model that evolves as the Fabric environment grows. The final baseline area is secure operations. Define who can create workspaces, who can create workspace identities, who can manage customer managed keys, who can configure gateways, and who can publish production reports. Use deployment pipelines and Git integration where appropriate to reduce uncontrolled changes. Document recovery steps for deleted identities, disabled keys, failed gateways, and accidental sharing. Train creators on sensitivity labels. least privilege, direct link security behavior, and safe sharing. Security succeeds when users understand the guardrails. Fabric should empower teams, but it should empower them inside a well-governed operating model. Let us bring everything together. Microsoft Fabric Security is a layered architecture that starts with Microsoft Entra ID and extends through conditional access, workspace roles, item permissions, compute permissions, OneLake data security, network isolation, encryption, workspace identity, customer managed keys, Microsoft Purview, DLP, audit logs, compliance, and resilient operations. The goal is not to make analytics harder. The goal is to make analytics trusted. When Fabric is secured properly, organizations can move faster because data owners, security teams, engineers, analysts, and business users are working inside the same governed platform. Thank you for watching, and I hope this deep dive helps you build a safer, stronger Microsoft Fabric environment.